Hi guys, and welcome back. So we're going to continue looking at examples with integration by substitution. So let's go ahead and just dive right in. The next one that we have is the integral of x cubed times x to the fourth plus 3 squared dx. So again, we need to figure out what our u is going to be. Let's take a look at the first term. The derivative of x cubed would be 3x squared. I don't have an x squared term anywhere in here, so that can't be our u. Let's check out the next one. The derivative of x to the fourth plus 3 would be 4x cubed. And I actually have an x cubed sitting right here. So this is going to be our u. We're going to go start. So u equals x to the fourth plus 3 du would be 4x cubed dx. And then we solve for dx. So that's going to be 1 over 4x cubed du equals dx. All right, so we're going to go ahead and start this process. Now, the first term, x cubed, did not have a direct substitution, so we're just going to rewrite it as x cubed. The next part was our u, so u squared, and dx is now 1 over 4x cubed du. And sure enough, the x cubes are going to cancel. They are gone. So we're going to rewrite. And I also notice that I have a 1/4 sitting here. So I'm going to put that on the outside of my integral. So 1/4 integral u squared du. And here we go. We're going to integrate. So we're going to add 1, divide by the sum. I'm going to bring down the 1/4. That gets multiplied by 1/3 u to the third, and then plus c. And we're going to simplify. A fourth times a third is 1/12. I'm going to replace u with x to the fourth plus 3, all cubed, plus c. There we go. All right, next one. We have the integral of t times the square root of t squared plus 2 dt. Now, the first thing I'm going to do before I do my u's is I'm going to rewrite this so that there's no square roots. So I'm going to do integral of t, and then t squared plus 2, and then a square root is the same thing as a 1/2 power, and that's dt. All right, so now it's time to decide what u is going to be. The first term, if we take the derivative of it, will just give us a 1, and that has nothing that's in here, so we can't use that, which means our u must be this. So let's do u equals t squared plus 2. We're going to derive, so du equals, let's see, that would be 2t dt, and then we solve for dt, so that's 1 over 2t du equals dt. And now we're going to go ahead and do our substitution. So first term, nothing happened. We're going to bring the t down. The next part, t squared plus 2, that's our u, to the 1/2 power, and we replace dt with 1 over 2t du. So first thing that happens is the t's here will cancel, and now I have a 1/2 that I can put on the outside of the integral. So we're going to rewrite. I'm going to have 1/2 integral of u to the 1/2 power du. And now we're going to integrate. So we're going to add 1 and divide by that sum. Now 1/2 plus 1 is 3/2. So that's what I'm going to divide by. And to get this next part, we're going to bring down the 1/2. And when you divide by 3/2, it's the same thing as multiplying by the reciprocal of 3/2, which is 2/3. Okay, and I'm going to bring down the u, and 1/2 plus 1 again was 3/2, and then plus c. And now we just have to clean this up. A half times a third is a third, or I'm sorry, a half times 2/3 is a third, because the 2's here would cancel, this guy here and this guy here. And u was originally t squared plus 2. And that's all to the 3/2 power, and then plus c. And there we go. All right, So moving on, let's take a look at a trig function. So in this case, we have the integral of pi times sine of pi x dx. Now again, if you can, look for any coefficients that you want to take out. Now remember that pi is not a variable, it is a coefficient. So I am actually going to plan on taking that pi on the outside of the integral. Okay, now the next part, all we're going to have in here is this sine of pi x. Okay, now I know that I have a rule for integrals that the integral of sine pi x is negative cosine. Okay, but that's only if sine is of a single variable. This is not a single variable. This is not an x or a t or a u. It is a pi x. Okay, now anytime you have a trig function of anything other than a single variable, usually that will be the u automatically. Okay, so we're going to start with that, and I'll show you how that works. So let's say we go ahead and start there. We're going to have u equal pi x. Now the derivative of that, remember that pi is a coefficient. So if this was 3x, okay, 2x, 5x, what would the derivative be? It would be whatever this coefficient is. So our du is pi dx. And again, we're going to solve for dx. So I'm going to do 1 over pi du equals dx. And now we're going to go ahead and do our substitution. I'll show you how all this works out. Now the first thing that we did is we took pi on the outside. I'm going to rewrite the integral, sine. Okay, we didn't replace sine with anything. It's still just sitting there. But now instead of pi x, it's just of u. Okay, now the dx part, that was 1 over pi du. Now, what's really cool about this is, granted, 1 over pi doesn't really help us much, but it helps us in the case that 1 over pi and this pi will cancel. So that was actually really helpful. It's one less step I have to do in this maze of integration. So what we have now is just the sine of u du. So we integrate and we get negative cosine of u plus c. Now the last thing that we do is we resubstitute our u, so our full answer is negative cosine of pi x plus c. There we go. All right, we're going to do one more in this lesson before moving on to more. So in this example, we've got a whole bunch going on. Now our variable in this case is theta. So we have the integral of 1 over theta squared cosine of 1 over theta d theta. So since this is a little much going on here, we're going to go ahead and work this one term at a time to figure out what u is going to be. So keep in mind that usually whatever your trig function is of, this part, the 1 over theta, will usually be what your u is. But I just want to double check and make sure that we're doing this correctly. Now, let's take this first term. I'm going to rewrite that so that it's not a fraction. In other words, theta to the negative 2 power. Now, if we were to derive this, I would get negative 2 theta to the negative 3. Now, this theta up here, okay, is to the first power. That is nothing of any kind in terms of a 3. Okay, so that 1 over theta squared is not going to be our answer for u. Okay, so let's take a look at the 1 over theta and check that out. Now that, without a fraction, is theta to the negative 1. If we were to derive that, we would have negative 1 theta to the negative 2. Now, if you remember carefully, when we rewrote this theta, it was to the negative 2 power, and that's what we're getting right here with the exception of the negative. So this is going to be our u, the 1 over theta. So we're going to go ahead and start that process. So u equals 1 over theta, okay, du, we've already done the derivative. It's negative theta to the negative 2, or in other words, just so that you can see it in both ways, this is negative 1 over theta squared. It is the same exact thing, okay? If you don't know your negative exponents, this is going to prove to be very difficult for you, okay? And then our d theta. We solve for d theta here, okay? Now, when I divide both sides by 1 over theta squared, it's the same thing as multiplying by the reciprocal of this, okay? So the reciprocal would be theta squared over 1, or just theta squared. So when I make this go over here to this side, it's just negative theta squared du, okay? Now, if you'd like me to slow that down a little bit for you, I will do that right now. Okay, I just want to make sure everybody's on the same page as I am. So let's say we go ahead and do this the long way. We're going to divide both sides by 1 over theta squared. So I would have du over negative 1 over theta squared equals d theta. Okay, so of course this is the same thing. We're dividing by a fraction. So we would multiply this by theta squared over negative 1 to cancel this out, and then we would just get this back. So just want to make sure that that makes sense for you. All right, so we're going to go ahead and do our substitution. The first term we have done nothing with so far, so we're going to rewrite it as 1 over theta squared. Cosine is still just cosine, and now we have u, and d theta turned into negative theta squared du. Now, the theta squared here and this theta squared just cancel each other out, okay? And this negative you can leave in front of the cosine if you choose, or you can put it on the outside of the integral. I choose to put it on the outside of the integral all the time. It just makes this process a lot easier, but it's really up to you. So we're going to do our cosine in here of u and then du, and we're going to go ahead and integrate. So the integral of cosine is sine. We're going to bring down the negative, write sine here instead. Okay, and then u originally was 1 over theta and then plus c. There we go. Stick around for part 4 for more examples. Thanks for watching.